Again, welcome back to Precalculus. In these lectures, we are going to learn how to solve system of linear equation with three variables. So our main objective is to solve system of linear equation with three variables. Now, there are so many methods in solving this problem. In linear algebra, we can use determinants. We can also use matrices to solve it. Here we are going to use, this is a precalculus, so we're going to use a different method. So first of all, let's go through what is a linear equation with three variables. So that's example here, ax plus by plus cz equal to d. This is again a first degree linear equation in three variables. Our variables will be x, y, and z. And we are assuming a, b, c, d is a constant values. Now, the three linear equation in three variables may look something like this. In our next slides, we will see it. But first of all, same thing as a system of linear equation with two variables. We have three possible solutions. Either we get a unique solution, or infinity solution, or no solution. And this is how, again, system of linear equation with three variables will look like. Now, the method we are going to use here is that we are going to do some multiplication, addition, interchanging rows until we make sure that x, the first leading x value here with my cursor, which is the first row, first column, is only 1x. Then again, second row, first column, x will be 0. Then same thing, third row, first column, x will be 0. So we want zeros in the first column, second row and third row, zeros. Then we also want 0 in our second column, third row. So imagine if I have 0 in a third row, first and second column, that means we know the value of z. So when I know the value of z, then I'll come to the second equation. Now in the second equation here, you can see that we already know that x is 0. So we can find the value of y because we know we can substitute z value here. So now we know the value of y and z. Then we can go up the first equation, substitute y and z, then we find the value of x. So that's the method we are going to use. And this method is called left to right elimination method. You can see we are eliminating from left to right. Let's go back again. We're going to eliminate the first column, second row, and third row. Then to the we eliminate also second column, then the third row. Then we start to substitute. So let's see an example here. So here we have 2x plus 4y plus 5z equal to 4. S minus 2y minus 3z equal to 5. S plus 3y plus 4z equal to 1. So the goal here, they say we should solve this equation, which means we have to look for the value of x, y, and z. So our objective is that the first row and the first column, we want 1x. Here we have 2x. But luckily, in the second row and the third row, we have ss. So we can interchange the first row with the second row or the first row with the third row. Here we decided to interchange the first row with the second row. So this is our new equation now. So interchange the first two equations. So we achieve our first goal. Now we want the first column, second row value to be 0. How can we make it 0? Let's multiply -2 to the first equation, then we add it to the second equation, then we keep that solution for second equation. So that's what we did here. We say multiplying add -2 times equation 1 to equation 2, and that will give us zeros here. Then we do the same thing for now in the third row, we can see we have 1. So we can multiply the first equation with -1, then add it to the third equation, keep it. So in this case, we achieve the first column, second row and third row will be 0, 0. And that's what we have here. But let's do some calculations here. So first one, -2 times s will give me, again, -2 times s will give me -2s. -2s plus 2s will give me 0. So that's why we have 0x here. Then -2 times -2 give me +4. Positive 4 plus positive 4 give me positive 8y. That's why we have 8y. Negative 2 times negative 3 will give me positive 6. Positive 6 plus positive 5 will give me 11z. And the last negative 2 times 5 will give me negative 10. Negative 10 plus 4 will give me negative 6. So it's the same thing we do for the... So we have our zeros now. How do we get the third row? Same thing we did. So we multiply negative 1 with the first equation, then we add it to the third equation. So negative 1 times x will give me negative 1x, negative 1s plus x will give me 0x. Negative 1 times negative 2 will give me positive 2, plus 3 will give me plus 5y. Negative 1 times negative 3 will give me positive 3. Positive 3 plus positive 4 will give me 7z. Then negative 1 times 5 will give me negative 5, plus 1 will give me negative 4. So we finish. Now, one last thing left is we want our third row, second column to be 0. Then if the third equation we have 0x and 0y, then we know the value of z. Z will give us whatever value here. Let's say if it's 7, then it will be z equal to negative 4 over 7. But the 7 will change. So let's see. So we decided, okay, the best way to do this, add negative 5 by 8 with equation 2 to equation 3. So doing this to equation 2 and add with equation 3, you can see this will give negative 5, 8. And we add it times equation 2 and equation again 3. So let's do the first one. Negative 5 by 8 times 0 is 0, so we leave that section, times 8 will give us negative 5. Then we add it to equation 3. So we can see that we are going to get negative 5 plus positive 5. And that gives us again the 0 here. Then we do the same thing, negative 5a times 11. Then we add it to 7, and that will give us the value here, etc. So now we finish. We have 0 here. So this means the third equation is 0. This means we have 8z equal to negative 2a, 2 by 8. So this means 8 will cancel 8, and z will give us negative 2. So that's why we have negative 2 here. You can see the 8 here will cancel the 8 here, so z equal to negative 2. Now, if z equal to negative 2, I'll go to the second equation. So we are going to get 11 times negative 2, which will give us negative 22. Then negative 22 is possible we have again. So that's what we did here. So let's look at the substitution here. First of all, we found y. I think that will be more quicker. So y will give us negative 6. This will go negative 11 minus negative 11z over 8. And that's what we have here. Now we can substitute negative 2 here now. Then solve this problem, we get 2. All is the same. I can multiply here 11 by negative 2, which will give me negative 22. And take it to the right to be positive 22. And then we bring the 8. 8 is multiplied y, so it's going to divide. So that will still give us the value of positive 2. Because we get 16 divided by 8. Now, we know the value of x to be negative 2, y to be positive 2. So let's substitute everything here. Here also, if we like, we can find x first. X equal to what? 5 plus 2y plus 3z, because negative 3z, negative 2y, when they cross the equal sign, they are going to be addition. That's what they did here. When we solve it, we get 3. Or if you like, we can just substitute it straight. 2 times 8 is 16. 11 times negative 2 is negative 22. So we have, no, sorry, I'm using this. So I'm using the second equation. Actually, I'm looking for x, so I have to use the first equation. So we have negative 2 times y, 2y will give me negative 4. Negative 2, 6, it will be positive 6. So if we solve the equation here, surely we are going to get 3. So let's see another example then that will be enough. So this is a second example, the same process. Here, we don't need to do any interchange because x is 1. But 2x here, we have to make it 0x. Negative s here, we have to make it 0x. Then this y, we should make it 0y. Then we can get z. Then we substitute z in the second equation. We find y. We substitute y and z in the first equation. We find x. So the first thing we do here is, how do we get this 0 here? We decided to multiply -2 with the first equation, add it to the second equation. Then the 2s will be 0x. So that's what we write, a -2 times equation 1 added to equation 2. Then we do the same thing. How can we get 0x in the third row, first column? Oh, it's straightforward, because the first row, first column is +1. Second row, third row, first column, -1. So we can just add the two together. So we add equation 1 and equation 3, and we get a new equation 3. So that will give us 0. Then 3 plus, this will give us 3, 2y plus 1y, 3z, and also this will give us 4. So that's why we have 3y plus 4 is equal to 10. Now the goal here is to get this 3y, 0y. And in order to do that, we say, okay, we should multiply 3 by equation 2, then we add it to equation 3, and that gives us the 0 here. So now we know the value of z. Z will give us +1. So here we try to write the equation 1 to solve for s, equation 2 to solve for y. So x will give me 6 minus 2y minus 3z. Y will give me minus 6 minus plus 4z, but it's -y. So positive y means I'll change the sign. So that will give me plus 4y, then minus 4z. And that's what we have here. So first we find the x and then the y. We know the value of, first of all, we have to find y because we know only the value of z. So we substitute z. Z is 1. When we substitute, y gives us 2. So it's 6 minus 4 times 1, 2. Then we substitute for x, 6 minus 4 minus 3. And that will give us, again, -1. So our solution will be s equal to -1, y equal to 2, z equal to 1. So that will be the conclusion of this lecture. So again, in these lectures, we learn how to solve system of linear equation with 3 variables. Again, there are so many methods we can use. For now, we use a very simple method called left to right elimination method. Again, thank you.